Okay, welcome back to Mr. Hassan's Maths channel. I'm now answering question number 4 from the June/October 2020 Statistics S1 paper from the International A-Level Edexcel exam. And this question here is about analyzing and displaying data in terms of box and whisker plots and outliers and these kind of issues. Now, a group of students took some tests. A teacher is analyzing the average mark for each student. Each student obtained a different average mark. For these average marks, the lower quartile is 24. The median is 30. So let me just start writing some of these things down. The lower quartile, Q1, is 24. The median, Q2, is 30. They've told us the interquartile range is 10. And the three lowest average marks are 8, 10, and 15.5. 8, 10, and 15.5 are the lowest marks. And the highest marks are 45, 52.5, and 56. So what's missing from here is the upper quartile. The teacher defines an outlier to be a value that is either more than 1.5 times the interquartile range below the lower quartile or more than 1.5 times the interquartile range above the upper quartile. So those are the limits for the outliers. So determine any outliers in this data. So for us to determine the outliers, we have to know what Q3 is. Now we know that the interquartile range is the difference between the upper quartile and the lower quartile. So the interquartile range 10 is equal to the upper quartile, which we don't know, minus the lower quartile, which is 24. So therefore we can say that the upper quartile is equal to 10 plus 24. So the upper quartile is equal to 34. So that's the upper quartile. So we've got to determine the outliers. Now, let's look at the lowest limit, or the lower limit, we can say. The lower limit for the outliers. So we'll look at that first. Let me just make some space here. Just going to write a bit neatly. Okay, so we're looking for the lower limit for the outliers. So let's start off with that one. So the lower limit. Okay, so as we know, the lower limit is the lower quartile, Q1, minus 1.5 times the interquartile range. Okay, so Q1 we know is 24, minus 1.5 times the interquartile range, which is 10. Okay, so it's 24 minus 15. Okay, 24 minus 15, which is 9. Just make sure. 24 minus 15, which is 9. So that's the lower limit for the what are called outliers. And we're going to look at the upper limit for the outliers. The upper limit is Q3 plus 1.5 times the interquartile range. So that's going to be Q3, which we worked out to be 34, plus 1.5 times the interquartile range, which is 10. So it's 34 plus 15. 34 plus 15, which is 49. Okay, 34 plus 15, which is 49. Okay, that's the upper limit and that's the lower limit. So we can say that the outliers are anything that's below 9. So you can see that below 9, we have 8. So outliers, I'm just going to list them. On the lower side, we have 8. On the upper side, anything above 49, which is these two, 52.5, 52.5, and 56. Those are the outliers. So that's the answer to part A. Right, so part B says, on the grid below, draw a box plot for these data, indicating clearly any outliers. Okay, so let's just write down what we have. We have the lowest value, okay, and this is 8. Okay, and it's an outlier. All right, and the lowest value inside our range, okay, is going to be, if we go here, it's 10. So the lowest value inside our range is 10. Okay, this is an outlier. That's the lowest value inside our range. So that's as far as the whisker is going to go. We know that Q1 is 24. We know that Q2 is 30. Was that right? Q2 was 30. Yep, and Q3 is 34. Q3 is 34. Now the highest value inside our range, Okay, the highest value inside our range is 45. So we got 45 as the highest value inside our range. And then the outliers are 50, 2.5 and 56. So these are the information, the pieces of data that we have to include in our box and whisker plot. So let me start with the box. The box goes from 24 to 34. Okay, so what I'm going to do is I'm going to draw, I'll do it a bit neatly with this, from 24 to 34. So 24 is here to 34, that's 35, so 34 is here. Okay, so that's from 24 to 34. So that's the low quartile, that's the upper quartile. Now the median is 30. That's Q2. One second, what's going on there? The median is 30, which is going to be right over there. Okay, let me just make it a bit. Okay. Okay, that's the median value. Okay, now we got to do the whiskers. Now the whiskers go. Now there's two different methods you could use. You could take the whiskers to the limit of the outliers, or you could take it to the last value within the limit, and that's what I'm going to do. So I'm going to go here, the lower limit up to 10. You could have a whisker going up to 9 if you want, and stop there, but I'm going to stop here, and it's perfectly fine to do either of the two. I think in the mark scheme for this paper, they actually just only include this particular method in the answer, like the visual answer, but they do mention in words that the limit can be going to 10. Now, some of the older mark schemes actually have both methods shown on the same diagram. One of them shown like with a dotted kind of line as well. So they'd have a dotted line going here to 10. All right, and some students ask, what's this other line? Why are there two lines for the whiskers on the same side? And they're just showing two different methods. One would be up to the last value within the limits, which is what I'm going to do. Or you could go all the way to the actual limit itself. Okay, so over here I could take the whisker. Well, I mean, if you do one thing on one side, you follow the same format on the other side. So here I'm going to go up to 45. Okay, I'm going to go up to 45 because that's the last number in our data which is within the limits. Okay, which is within the limits. That's what I'm going to go. Now, if you were to go all the way to 49, which is the limit of the outliers, that's perfectly fine. That's a perfectly fine method of dealing with it as well. Okay, so it really doesn't matter. Okay, so I'm going up to the last values within the limits. If I took this all the way to 49, I took this all the way to 9, that would be fine because those are the limits. Right, both are correct, but we have to also now mark the outliers. We have to mark the outliers. So the outliers are 8 on this side. So that's the outlier on this side. And on this side, there's two outliers, 52.5, 51, 52.5 is over here, and 56, which is over there. So here I've marked the outliers with crosses, which are outside this region here. So there's the answer to part B. So on the grid below, draw a box plot for these data indicating clearly any outliers. So those are the outliers marked with X. All right. So that's part B. That's done. Question part C says, use the quartiles to describe the skewness of these data. Okay, so we have Q1 is 24. We have Q2 is 30. And we have Q3 is 34. Okay, so we can see very clearly that Q2 is closer to Q3 than it is to Q1. All right, and so this is going to have negative skew because the data is more concentrated on the higher values. If you were to draw a distribution, it will look something like this. It would be more concentrated on the higher values, so the tail would point to the left, so it's going to be negative skew. So we can say, as you could do in many, and you can write in many ways. We could say Q3 minus Q2 is less than Q2 minus Q1. Therefore, we can say negative skew. We could also mention, for example, that Q2 is closer to Q3 than Q1. Therefore, negative skew. You can mention it like that if you want. You're using the quartiles to describe the skewness of this data. So in this negative skew, and that's the reason. So 2 marks, 1 for getting the description of the type of skew, and 2 for giving a reason based on the quartiles. Okay, so there's part C of this question done. Now we're going to go on to part D. Okay, so here it says 2 more students also took the tests. Their average marks, which were both less than 45, are added to the data and the box plot is redrawn. The median and the upper quartile are the same, but the low quartile is now 26. Okay, so this is the data from the last page. So the low quartile now is 26. The median is the same. Okay, the interquartile range is now going to change. This is Q1, this is Q2. So we can say that now we have, let's say Q1 is 26. Q2 is unchanged, which is 30. Q3 is unchanged, which was 34. Okay, let me just make sure that was correct. 34 was Q3. Yes, that was what we found. Q3 was unchanged. The lower quartile is 26, median is 30, and the quartile. No, sorry. It says the median and the upper quartile are the same. Good. Okay, and the lower quartile is 26. All right, now. Okay, so that's the new information about the quartiles. It says here the art were both less than 45 added to the data plot redrawn. The median upper quartiles are the same. The low quartile is now 26. So let me just do the box plot here. So we can do the box plot again. Now in this case, what's happened here is the median. So the Q goes from 26 to 34 now. So 26 to 34. So the interquartile range is now different. Okay, so that goes from 26 to 34. All right, and the median is 30. So the median is right in the middle now. Looks like it. It's kind of symmetrical now, isn't it? Okay, that's the median now. All right. Now, let's see. The average says 2 more students are added. Okay, which are both less than 45. Okay. The median and upper quartile are the same. Okay, and the low quartile is now 26. Okay, so now that means that we've got to work out the new interquartile range and therefore the new outliers. Okay, we've got to find the new outliers. Okay, the new range of the new upper and lower limit. So now the interquartile range has now become 34 minus 26, which is 8. So we can say that the new lower limit, has changed. So it's the low quartile. It's Q1 minus 1.5 times the interquartile range, which is 26 minus 1.5 times 8. And the upper limit has also changed because the interquartile range changed. That's going to be Q3 plus 1.5 times the interquartile range, which is 34 plus 1.5 times 8. So let's see how that affects the outliers. So you have 26 minus 1.5 times 8. That gives you 14. That's the new lower limit. And for the upper limit, you have 34 plus 1.5 times 8, which gives you 46. So those are the new limits of our data. So let's have a look here. We got down to 14. Now what are our values? 8, 10, and 15.5. So the lower limit is now 14. So we're going to go down to 15.5. Okay, so this goes down to 15.5. Okay, so you're going to go down to 15. That's 15.5, somewhere over there. So that's as far as that one will go. Let me just make that a bit smaller. Okay, so that's 15.5 over there. Okay, and the upper limit, it's now 46. So let's see what values we have. The 3 highest are 45. So 45 again is still the upper, it's the lowest value, it's the highest value within our limit is 45. That's the highest value inside our limit. Okay, so that's going to be up to there. Make that thinner. Okay. So there we have, let me just make that a bit more accurate. Okay, so there we have our box and whisker plot, which is now with these new limits, and they're going to show the outliers. So now for the, we have two outliers now here. We have the outliers being 8 and 10. So one outlier here is 8 and 10. So there's one there and one there. The next value is 15.5 in our range, and the limit was 14. Okay, that's fine. And the upper limit, the outlier, there's still the same two outliers, 52.5 and 56. 52.5, that's 52.5 and 56. So now we have an extra outlier on this side. Okay, so there we have the new plot drawn, okay, with the new information in it. Okay, so now we're going to go on to part E. Okay, now for part E. It says, give ranges of values within which each of these students' average marks must lie. So they're talking about these two more students. So there's two values that have been added to the data that caused this to happen. It caused the median and the upper quartile to be the same, but the lower quartile to increase from 24 to 26. All right, so how does that work? Now, let's take a look at the data from the previous part of the question. This is our box and whisker plot. So two pieces of data were added, which caused this to stay as it is, and this to stay as it is, but this changed from there to there. So Q1 moved from there to there, to 26. This is 24, this is 26. But these two stayed where they were. They stayed where they were. All right, so now, what would cause the median to increase from 24 to 26? Okay, now, how can we think about that? All right, so a lot of students get confused about, you know, when you add a number before or before the median, what does it do? After the median, what does it do? Sometimes you don't understand, you know, it's difficult to picture. So what I'm going to do here is I'm going to just put a set of values, not these values, just a set of random values, just to show you what happens when we modify the data or add bits to the data, see what it does to the median. So, I mean, this is not like the working for this question. And this question is only worth 2 marks. We only have to write down the answer. We don't have to give any explanation. But I want you to understand what's happening. Right? A lot of students have problems with this type of question. So I might take a bit longer than you might like, but this is, I want to make sure that everyone understands. So just imagine we have a set of data like 2, 4, 6, 8, 10, 12, then 14, 16, 18, 20, 22. Now in this set of data, okay, the number right in the middle is 12. This is Q2, because you've got here 5 numbers to the right of it, 5 numbers to the left of it. Now with these 5 numbers, you could say that this is Q1, because it's right in the middle of these 5 numbers, and this is Q3, sorry. All right, so that's Q1, Q2, Q3. All right, that's right in the middle of these numbers here. So that's the lower quartile, the median, the upper quartile. All right. Now, supposing I add a number, for example, before less than 6. Just say I add a number less than 6. Say I put a number here 5. Now, within this set of data here, if we just concentrate on this set of data here, what's going to happen is the lower quartile is going to shift to a number lower than this. It's going to shift to a number lower than this, right? It's going to become lower than that number, all right? So adding a number lower than the lower quartile causes the lower quartile to decrease. But adding a number greater than the lower quartile increases the lower quartile. So if the lower quartile moved from 24 to 26, then the number that must have been added here must be more than 24. In fact, it must be more than 26. Okay, because 26 has to become the new lower quartile. So it could be 26 or more. Okay, if it's less than 26, maybe there's the number 24. If if there's a number between 24 and 26, that number would become the new lower quartile. Okay, we want 26 to be the lower quartile. So if there's no other 26s there, from 26 and above 26, that's the possible values for a number that can be added for the lower quartile to become 26. Okay, so any number between 26 up to 30. Okay, why up to 30? Because the lower quartile, the median and the upper quartile didn't change. Okay, so if I add a number here, okay, this is going to increase the lower quartile. Okay, it's going to increase it. All right, so one number must be between the first extra number must be between, you can say 26 to 30. It has to be between 26 to 30 because the low quartile has increased up to 26. All right, it has increased up to 26. So it must be somewhere between 26 and 30. Why can't it be more than 30? Because the median didn't change, nor did the upper quartile. Okay, but there's two numbers that were added, of course. Now, if I add the second number, for example, between Q2 and Q3, right, somewhere between these two, it's going to cause this to remain the same because I add a number here and I add a number there, this stays in the same place. But it's going to cause the lower quartile to get less, the upper quartile, to get less. All right, it's going to cause this to get less. Okay, because, it's going to be a number less than this upper quartile, right? So it's going to cause this to become less. Right, it's going to make this stay the same because you've added a number on this side of it and you've added a number on that side of it. Now this is going to become less because you've added a number less than it and another number less than it. So it's going to make it come less even more. But if we add the second number somewhere over the upper quartile, then, this number has been added in. So it's increased the numbers to the left of Q2 and to the left of Q3. If I add another number after both of them, it's going to keep these two in the same position. These two won't change their positions now. This number after Q1 will cause Q1 to increase, and it would cause these two to decrease. It would cause these two to decrease. But if I put the other number after those two, it will cause these two to go back to their original Q2 and Q3, but this has increased. So the second number must be between, it must be bigger than Q2, bigger than Q3, but less than 45. Why less than 45? Because the question tells us they're both less than 45. Okay, so it must be more than Q3, which was 34. It must be between 34 and 45. So if you put one number between 26 and 30, it will increase the lower quartile. Okay, and if you put the other number between 34 and 45, it will keep these two the same, but still increase the lower quartile. And we want the lower quartile to increase to 26, so the number that must be put in must be at least 26. Okay, because it has to be at least 26. All right, for it to increase it to 26. So there we have the answer to this question, part E. I hope that was clear. As I said, this first part here that I drew out, you don't really need to. You don't have to show this step at all. This is nothing to do with the question. I just wanted to illustrate to you how that basically works. Okay, just to give an idea of what happens when you slot a number in before or after, what happens to the lower quartile, how it changes, and so on. Okay, so if you slot a number in before and after a particular quartile, it keeps the quartile the same. If you add like Q2 and Q3, if I add a number before Q2 and Q3 and after it, it keeps both of them in the same position. So adding the number after Q1 will increase Q1, okay, and then adding another number after Q2 and Q3 will keep these two the same. Keep these two the same, but this has going to be increased. But we want it to be increased at least to 26. Okay, it must be between 26 and 30 because it says here the upper quartile has now become 26. All right, so it can't be, the number you add can't be, for example, 25, because then it will increase to 25. It has to be, it could be anywhere between 26 up to 30. It can't be more than 30 because we want it to We want the other number to be going after those two, which will cause these to stay in the same place. So I hope that's clear. Other questions from this particular paper can be found in the playlist that appears over here. That's the June-October 2020 paper. Other questions from this topic of data analysis and I'd say box and whisker plots will be found in this playlist over here. You can subscribe to my channel by clicking on this link. Thank you for watching. Don't forget to look at the description underneath the video to get other material that you might be interested in. See you soon.